Okay, picture this. You've just spent time writing out some brilliant Python code. You go to sort your list of data, you hit print, and instead of your beautifully ordered items, a completely blank variable stares back at you. It returned none. Honestly, we've all been there, and it's a terrifying moment. But today, we're going to fix that forever. Welcome to this explainer.
Here's what's on the agenda today. First, the big list scotches. Second, sorting, in place versus new lists. Third, adding elements and the dreaded nesting trap. And finally, a quick preview of list comprehensions. Let's get right into it.
Section 1. The big list scotches, and exactly why list methods seem to break your code.
Moving right to Section 2. Sorting, in place versus new.
So let's look at our first major battle, the infamous sort versus sorted showdown. This is arguably the most frequently confused pair of operations in the entire Python language. You write sorted list equals mylist.sort, right? You completely expect that new variable to hold your shiny ordered items. Instead, it holds absolutely nothing. So why exactly does Python do this to us?
Well, spoiler alert, it isn't a bug, it's a very intentional design choice. Python deliberately returns none for the sort method to protect you. It stops you from accidentally overwriting your original list variable, and it saves memory by modifying the list right there in place. On the flip side, the built-in function sorted leaves your original list totally untouched and hands you a brand new separate copy.
You can clearly see this in action here. When you call nums.sort, it instantly shuffles the actual nums variable in place. But just below that, when we assign sorted original to new list, that original variable remains entirely untouched. Oh, and as a quick bonus, you can even sort by custom keys using a simple lambda function, like if you wanted to count the sugar inside a tuple.
But listen, forgetting that sort returns none will literally destroy your data. You'd think you're saving a newly sorted list, but nope, you're just saving none. So you have to make an explicit choice. Either sort your list in place by calling the method entirely on its own line, or use sorted to generate and save a brand new list safely.
All right, Section 3. Adding elements, and specifically, the nesting trap. This brings us to the append versus extend dilemma. To avoid building a weird list inside of a list, understanding what an iterable is becomes your master key. Really simply, an iterable is just anything in Python that you can loop over. Think lists, strings, or tuples.
Let's say you're making a recipe. We have a base list of water and milk, and we want to add ginger and cardamom. Appending that new list takes the whole package and just shoves it in as one single chunky item. Boom, you've got a nested block. But extending unpacks everything. It opens up that new list and adds ginger and cardamom as separate individual items perfectly side by side with water and milk.
So, if you want a reliable rule of thumb, here it is. If you want to add just one single entity, even if that entity is a whole list itself, use append. But if you want to unpack multiple items from an iterable into your base list so they sit completely flat, you use extend.
Okay, Section 4. A quick preview of list comprehensions. Now that we've tackled how to modify existing lists, let's look at advanced Pythonic list creation. A list comprehension lets you build a brand new list in a single, elegant line of code. No clunky multi-line for loops required. It just breaks down into 3 logical steps: an expression, a loop through your items, and an optional filter condition.
Honestly, you can just read this syntax like a normal English sentence from left to right. It's saying, give me this expression for every item in my iterable if a certain condition is met. It basically condenses 3 or 4 lines of code into a highly readable format, all wrapped up nicely in square brackets.
So how does this look in real-world code? Say we have a list of sugar levels. Using a list comprehension, doubling those numbers is effortlessly x times 2 for x in sugar levels. Or what if you just want to filter out the even numbers? Simple. It's just x for x in sugar levels if x% of 2 equals 0. This is a seriously powerful pattern that you'll spot everywhere in professional Python code bases.
Section 5. Flashcard wrap-up. Test your knowledge. Let's do a rapid-fire review to lock in what we've learned. See if you can beat me to the answers.
First up, the absolute big one. What's the ultimate functional difference between our sorting twins, sort and sorted? Remember, sort alters the original list directly in memory and strictly returns none. Meanwhile, sorted keeps your original list perfectly safe and hands you a brand new copy. Question 2. How do we dodge the nesting trap? What is the difference between passing a list of numbers 1 and 2 to append versus extend?
Well, using append grabs that list and traps it inside your main list as one single nested element. But extend acts exactly like a zipper. It unpacks them as two separate integers at the end of your original list.
Okay, here's a bonus trap we hinted at earlier. How do you completely reverse a list in place without creating a new one?
Exactly like our sort method, list.reverse acts directly on the original list. And because it modifies that original in place, it also deliberately returns none. So whatever you do, don't assign it to a new variable.
And lastly, for our advanced preview, what is that magical one-liner formula for list creation?
It is simply expression for item in iterable if condition. So now that you've officially escaped the most destructive list operation gotchas, how are you going to use these powerful techniques to write cleaner, faster, and way more Pythonic code today? Keep practicing these patterns, always avoid that none return trap, and your future self will definitely thank you. Thanks for joining me on this explainer, and happy coding.